Thank you everyone for joining this session today. I'm audible? Okay, yeah, thank you everyone for joining this session. My name is Vinod. Today I'm going to talk about Kyverno and how you can use Kyverno in your Kubernetes cluster to govern the applications. Okay, now it's better, right? Yes. Okay, fine. Okay, so how many are you aware of Kyverno? Like any idea, like any policy as code? Okay, fine. So, right. So before that, let me Okay, so let me few things about me. So I have done Bachelor of Engineering. I graduated in the year 2008. Have 16 years of development experience across various business domains. So I started in manufacturing, then moved to the finance thing, and then to the government sector. Majority of my experience is into the government sector. I have worked with the Ministry of Transport in Singapore and then in the Saudi Arabia as well. Then currently I'm working as a principal engineer with Arcesium India Private Limited. I'm also certified in AWS, GCP, Azure, and in Kubernetes. Now, as a volunteer work, like I do a lot of time spending on the blogging plus open source contribution. So yeah. So here is the agenda for today's session. So I'll start with to set some context, I'll start explaining the challenges which we face in the application deployment, especially in the Kubernetes clusters. Then I'll give you an overview of what Kyverno is, some tenets about Kyverno, and the authorization, like what authorization looks like in Kubernetes, and specifically focusing on the Kyverno's perspective. Then I'll give an overview of how the policies and the rules will look like in the Kyverno, followed by a Kyverno demo and some takeaways in the end. Now, before I start this session, right? So, like, why do we have to govern something? Like, anyone can tell, like, what's the exact meaning of govern or governance?
Continuous check and monitoring to certain specs in terms of policy, because if anything is not compliant at the time of auditing and ISO, because the organization are ISO certified, so we have to give the audition before. So in a hierarchical way, everything comes up and doesn't show the good picture.
Exactly. So I'll take an analogy also. Let's say you visited a bank, right, as a customer, and you want to open a bank account. So banker, if they are following the protocol, they will ask you for identity proof, address proof, right, in order to open the bank account. Let's say they have not asked any of the identities, right? So they just open the bank account. Technically, they can still open it, right? So what will happen? Imagine there are hundreds of people where the bank account has been opened like that. So there are some policies, some which are laid by the Reserve Bank of India. They wanted to check, right, who is doing what. Otherwise, there can be some potential risk to the banking system. So people can do some money laundering also. There could be some cases can happen, right? And eventually the penalty, there could be scenarios where the RBI can impose some penalties on the bank, right? So we need to have some governance in place. Similarly to that, when it comes to the production application in your production Kubernetes cluster, right, we need to have some governance in place. So otherwise, everyone will do their own kind of deployment, right? So imagine, let's say this is your 3-node Kubernetes cluster, right? And there are multiple teams who are using this cluster for application deployments. So let's say there are team A, team B, and team C, and they're not following any kind of policies or any kind of your compliances which are laid down by your infra team or DevOps team. So what will eventually happen? Imagine, let's say the team A is doing some deployment, right, without any labels and all. Technically, their applications still work, but labels are very important. Let's say, I'll take an example. Let's say we want to derive some cost, right? Which team is burning a lot of cost, right? So we need some certain specific mandatory labels in place. Otherwise, we'll not be able to get the cost attribution done properly. Let's say the second team is again, doing the deployment on the Kubernetes cluster with some vulnerabilities. Like as Ram mentioned, there could be vulnerabilities in the Docker images. Let's say they are just using the Docker images from some public repository and they are running their application. So there could be some potential risk for that. And let's say the team C is following all the protocols and they are, deploying the application. So if we don't have any kind of governance in place, right? So there will be risk to the entire production applications. Some hackers can hack the systems, and it can be a challenge for the companies. So how Kyverno is going to help with that is Kyverno is an open source project. It's a pure Kubernetes native project, which is from the CNCF. Now it's something similar to the OPA or the Open Policy Agent. So how many are aware of OPA or Open Policy Agent? You're aware, right? Open Policy Agent. This is something similar to that, but it's, I would say, it's not a comparison between OPA and Kyverno. But if when it comes to OPA, let's say Open Policy Agent, right? It's not specific to Kubernetes. You can use OPA to govern your non-Kubernetes applications also. But when it comes to Kyverno, it's very simple because you are already familiar with the YAML notations or the JSON format, right? You can very well write the policies. I'll show you the policies, how it is going to look like in the end also. You don't need to read, learn any new language like the Rego. So if you see this example, right? So this example is about a Rego language, which is nothing but an open policy agent. But Kyverno makes it very easily because it's completely native to Kubernetes and it is built for Kubernetes. So these are few key tenets about the Kubernetes. So it's purely native to the Kubernetes, and it's highly customizable. Let's say you want to have some control or some policies defined for your deployments or from a daemon sets, you can highly customize that your policies. Let's say you want to have some policies in place where you want to restrict that your Docker images should be pulled from a private repositories. You can do that also. You can customize in that way also. And plus, Kyverno can be used to apply the policies as the cluster level as well as at the namespace level. If you want to have some policies, entire namespace level, cluster-wide, you can do so, or restrict to the particular namespace also. And like I also mentioned, you can write the Kyverno in the YAML as well as a JSON format. Plus, since it's a policy as code, you can very well, push these changes as a code to the GitHub repositories or the GitLab repositories. Okay, some little bit brush up on the authorization. Like I know it's a bit too technical, but yeah. So we'll focus on the webhook one. This is where the Kyverno works well, but I'll give a brush up on the other. So we have various authorization mechanism in Kubernetes. By default, you will see the RBAC, which is the role-based access control, but there are others also like always allow, always deny, attribute-based as RBAC and the node. So when you say the always allow in authorization mode, so if you, let's say, if you are running your Kubernetes on a managed cluster, right, like you're on AWS or GCP, you will not be able to see because the cloud vendor manages that. But let's say if you are running the Kubernetes on a Minikube or then you can go to the API server and see the configuration. So where there you will see an authorization mode like this, always allow. There could be other authorization mode also, always deny, RBAC and ABAC. Okay, so how, except that webhook one, how the flow works in whenever you make a call to the Kubernetes cluster. So let's say, for example, you are interacting to the Kubernetes cluster via kubectl command or via pure curl command. So your request first goes to the API handler where it will do some basic checks on the headers. Then the request will go to the authn or the authentication or the authorization side where your certificates or the username password will be authenticated first. Then it will check whether you can really access that resources or not. So I'll just have some water, sorry. Oh, sorry about that. Okay, so what happens, right? So whenever you make an API call, like I mentioned, so it first goes to the API header. It will check for the basic headers, and then it will go for the auth and OZ mechanism. So this is where your authentication will be verified. So let's say, for example, if you're accessing your cluster using username password, it will check you that thing. Or if you're using the certificate base, your token or the certificates will be validated. Then the request will go to the admission controller. Now, this is the main thing. So let's say everything worked well. Your authentication worked well. Your authorization worked well. Now it will do some prerequisite checks. Let's say it is trying to access the trying to create some the pods, but the namespace do not exist, right? So it will do some checks whether the namespace exists or not, and it will do some validating admission webhooks and mutating admission webhooks before creating that resource, and it will persist that information in the HCD store. So this is how your normal flow will look like. We'll see how the webhook will look like, because this is where the Kyverno works. So when the authorization mode is set to webhook, so this is where, and Kyverno will come to the into picture. So can someone tell me, like, what's the difference between a synchronous base call and a asynchronous base call? So what happens when when a client is making a synchronous based HTTP call, or when a client is making asynchronous based HTTP call? Can someone tell me the difference?
API is going to wait for a response to come. In async, it will carry on with the further stuff.
Right, exactly. So when it comes to a synchronous based call, your client will wait till the response is received from the server. And when it comes to the asynchronous based call, it will not wait, right? So what happens in case of the Kyverno also, assume it, you're interacting with the Kubernetes cluster and trying to create some resources, right? So that request will be intercepted by the Kyverno. It will check how it is going to work is your Kube API server is going to make a call to the Kyverno. A synchronous based call will be made to the Kyverno, where the Kyverno is going to check the policies which you will have created to verify whether that request is a valid request or not, and whether it's following the company's standards or the policies defined or not. Based on that, it will take three actions. It can mutate, it can deny, or it can approve that request. So once a response has been received, the Kube API server will take the necessary action. For example, let's say you want to create some pod, but the labels are missing, right? So that request will be evaluated by the Kyverno. And if the Kyverno says deny, then you cannot go and create the pods. And you will get a error on the screen. So Kyverno is good for does three things, like I mentioned. So it will mutate, it will validate, it will do some cleanup jobs also. Plus, it can generate the resources. Let's say, for example, if your company wants to, do some cleanup, right? So let's say there are jobs. We have Kubernetes jobs also. We have Kubernetes cron jobs also, right? So what happens, right? When a pod is created out of that cron jobs or jobs, right? So there will be entries left behind. So those are one-time jobs only. We need to have cleanup regularly. So you can use the Kyverno to have some configurations in place that will clean up your resources which have already been executed after, let's say, 24 hours or 48 hours, whatever you are going to define it. And how the flow will work in case of the Kyverno when it is a webhook based is, whenever the API call happens, in this case, again, the request will go to the header. The request will be authenticated and authorized by the API server. And this is very important, where the Kyverno, where the API server will make a call to the mutating admission control. Your API server will make a webhook call to the Kyverno. It will check whether there is any policy where I have to modify or mutate the incoming resource request. So Kyverno is very intelligent enough. I'll tell you one scenario. Let's say you have created some policies where you want to have some mandatory labels in place, but your team is not following that. So Kyverno can add those labels by itself before creating those resources. So that's what the mutating admission means here. You can create some policies and you can mutate your incoming request and before persisting into the etcd store. So once that part is done, it will go for the schema validation. Like the schema validation, like I mentioned, before creating some resources, let's say pod deployment, right? Your API server will ensure that the namespace exists. So those are the schema validation thing. And finally comes a validating admission. So this is again, your API server will make a webhook call to the Kyverno to ensure that that the request is following the policies or not. Let's say there can be some let's say you have some development namespace, right? And as per the company policy, no team can deploy or multiple replicas of an application. Let's say they want to restrict only up to 2 replicas of an application. You can define some kind of that kind of validations, and if the validation admission says deny, it will deny the request. You will not be able to schedule a pod on that particular worker node, or if it says approve, it will be scheduled. And that information will be again persisted into the HCD store, which is for the auditing purpose. So this is how Kyverno policies and the rules look like. So if you see here, right, so this is a cluster-wide policy, and the API version is kyverno.io/v1. And here, we need to define certain rules. So the rule is a 1:n. 1:n means in a single cluster policy, we can create as many as rules and to make your requirements customizable. So for example, if you see here in the sample cluster policy, you can see that this policy is applicable only for the kind as deployment. Means I want this policy to be enforced only on the deployment, not on the pods. If I want to enforce it on the pod, I can very well add a pod also. I can specify daemon sets, I can specify cron jobs, I can specify jobs. So I am telling, your policy will define where you want to apply that policy. Then there is a match label. Match label means where you want to match it. Then this is very important, where you are trying to just validate it. Validate in the sense means we are saying if this particular label app is missing, throw this error, which is you must have the label app for all the deployments. Similarly, you can think, right? So like I mentioned, if your team name is not mentioned, your DevOps team or the infra team will not able to attribute the cost, how much a team is burning the cost on a cluster. So some of the labels are very important from the company perspective. So similarly, we have validate, you can have mutate, you can have verify images and the generate. Like I mentioned, mutate, you can mutate an incoming request, add some necessary labels, and then it will proceed. So like that, we can have a cluster policies also defined. Now, very importantly, we have this validation failure action as enforce. Enforce means we will not allow until unless this policy gets passed. So it will stop the deployment right away itself. It could be warn, if you want to just send some warning without blocking, you can specify as audit. For example, this is again Kyverno policies, again in detail. The kind is cluster policy because we want to apply this policy cluster-wide and not specific to any namespace. Then we have the validation failure action, which is enforce. Enforce means we want to block the deployment, or it could be audit. Audit means we just want to send the warning, but we are not stopping the deployment. Then if you want to create any policy, right, instead of kind as a cluster policy, you can have a namespace as, the kind as policy, and this policy will be applicable on the namespace level, not the cluster-wide level. Okay, I'll show a quick demo also, like how the this thing works. So before that, I'll show a demo. Like before that, just this is the demo part of it. So where I'm trying to deploy an application, and I'll give the replicas, let's say more than 3. But the policy says I want to have a namespace specific policy where the development is my namespace, where I want to restrict the teams to deploy not more than 2 replicas. And there should be a label, that is a team name. So this is the the policy which I have already installed the Kyverno, but I'll give you the provide you steps also, just in the interest of the time, and I've already configured the policy. This is a non-working deployment file which I'm going to run, and it will throw an error. So Like I mentioned, in the interest of the time, so these are the things which I have done. Like will install the Kyverno, which is Helm is a recommended one, and then we'll apply the policy, and finally we'll see whether the policy is in enforce or not. If you want to see any policy which is enforced or not, you have to just tell Kubernetes kubectl get policy. If it is a namespace specific policy, you will just provide the namespace one, and it will tell you the policy name. And if you see here, it's ready is true, means the policy is active. And the validate action is enforced. That means it is going to block the deployment. So I'll give you quickly the code walkthrough also before I run this. So this is the one which I have used here. So here again, the validation failure action is enforced, and I'm putting only on the deployment. It is a name specific to developer namespace, and the replica count is, I'm expecting the replica count to be equal or less than 2 in this, as per this policy. Plus, there should be a label in the as a team name for the application deployment. So if I run this application, which is not following any compliance, right? So it will throw an error. And this error, if you see, right? So these are the one which we defined in the policy YAML file, which is check for YAML. That is, you must have a label, team name. And second error it has shown is you cannot deploy more than 2 replica count. And if I try to, redeploy the application by correcting the changes which were suggested. So let's say this is my valid policy, valid deployment file, where I have the team name as a label, and the replica is 2 over here. If I try to run this one, it will work. If I run this, it will work because it has followed all the policies that I have laid down. And I can go and check the dashboard also. So in the development namespace, my application is up and running. Yeah, so this is how the Kyverno works, but yeah, some of the key takeaways, like we learned why the governance is important in an application, deployment perspective. Then we also seen how the authorization works in Kubernetes, also in the webhook-wise, which is a Kyverno-wise. Then we deep dive into the Kyverno with some example policies and the demo. So here are some reference links and my recommended learning. So if you're really interested to understand, my recommendation would be learn authorization modes, like how each and every authorization modes works. So it will be very easy when you are trying to relocate, when you're trying to correlate with the webhook as authorization mode. So these are, if you want to connect with me, these are the QR code. And I can give you, last one more code walkthrough of how the mutating thing will work. So this is an example cluster policy for the mutating thing. Let's say, like I mentioned, if something is missing, you can have a mutate policy. Here, what I'm trying to do, I'm trying to add a label. If the application is not following, I'm trying to add a label, company, with a value as the my company. So when this policy will be enforced, so it is going to mutate that incoming request, and it will add that policy add that labels by itself. And this is applicable for pod and deployment. And if you want to, let's say, like I mentioned, if you want to have some cleanup automatically, right? So this is the policy, which look likes. So here the kind is a job over here, and I'm putting a check, which is after 24 hours, all my already executed jobs should get deleted, should get cleaned up, after 24 hours. So the policy will look like. Now all the source code I have already pushed to my GitHub repository. So you will see within here, within the Kyverno here, and it's there, like in this link. Thank you. I'm open for any questions. Thank you so much. Any questions? Yeah. Yep. It's every time. Let's say the moment if you're trying to create a resource, delete a resource, update a resource, every time the Kube API server will make a call because authorization mode is webhook. And here the Kyverno is acting as a webhook. So it will go and check, making a synchronous call, whether it's following a policy or not. So it's a synchronous call, and your request will wait. And then once the Kyverno decides, like I mentioned, it could mutate, it could approve, it could deny. Based on the decision or the response, the Kube API server will take the necessary action. Every time it will check. Security certificates that anyways will happen because let's say for where at anyways the API server is doing it. So let's say for example in your kube config, right, you will have the certificates configured, right? So that anyways the first level of defense with kube API server is doing it. Whether your certificates is valid or not, or in fact, not just certificates, like I mentioned, right? You can interact with Kube API server, not just by kubectl command, you can interact by curl command also, HTTP pure curl command also. There you can pass a token, there you can also pass a username or password. There also first level of defense is always a Kube API server. But this is more like, the policies which is meant for the governance perspective, like whatever your company is following it, right? Because in the end of the day, we don't want to burn the cost. The company wants everyone to be in sync. They want to check what labels, which team is doing it, and what they are doing it. In fact, you can put a check also that, like I mentioned, you should not be able to download the Docker images from public repository. So that level of customization also supported in Kyverno. There are templates available. So once you install Kyverno, right? Once you go to the documentation, you will see the all the information available there. Like there are some out of box also available. You need to enforce the policy. So if you go here, right? So this is more like the installation thing, but yeah. But if you read this policy and rule, so there will be some out-of-box policies will be defined, but you need to enforce it. You need to copy that, use it. So it's all about, regular expression, and not just that, right? I took an example of, namespace one, right? But there could be other application falling in the same namespace. I don't want to impact that. So you can have an expression in the Kyverno policy dynamically so that it just impacts some set of deployments which are part of that namespace, not all the deployments which are part of the namespace. So it's highly customizable. Can it generate logs? No, but I can check. But that's not what it is doing. It can generate the configuration. The logs, anyways, the Kube API server will generate. So if you see right that etct store, every request gets persisted in the data store etcd. That is used for auditing purpose only. Any other questions? Like I'm happy to take. Correct. Yes. You can use it. So for the detection mode, right? Like I mentioned. Yes, you will get a message. Yeah. So same message you will get it. So for the detection mode, what you have to do, this validation failure action should be marked as audit. So when it is audit, same error you will get it, but it will not stop you from creating the resources. Hi, resource will be created. But if it is enforced, you're enforcing it. Resource will not be created. Any other questions? Yeah, please go ahead.
Is of Kubernetes. For example, how do you handle such type of situations?
Sorry, I missed a little bit. Could you, the cost part, what? Team-wise distribution or how?
Maybe there are teams. We have generated all, we generate all the cost. Is this how things work?
See, that definitely will vary from company to company. So I'll take my company, like my company example, because mine is a fintech, right? So we burn a lot many amount on a per monthly basis. So there are bills I've seen $1,000 also on a per monthly basis. $2,000 also is goes on a per monthly basis, because the amount of the data we churn out, because it's a pure data engineering. So we have many clusters running, and we have GPU based clusters also running, right? So there are, from the company perspective, there is no restriction, but company will always like to reduce the cost. So what happens, right? So we generate the monthly cost, infra team generates a monthly cost, and that is distributed at an organization level, and it will tell you which team has burnt how much on that particular month. So we also has an OKR, key, the object is to reduce the cost. So we will see why, which particular piece of, infrastructure is taking more cost. Probably the database might be taking more cost, right? Probably the instances which we are using it, in reality, we might not be using it, right? So we want to bring that instances down. So best example is like, KDA and all, right? So we can bring the applications down if they are not being used, or we can scale out also if they are being used. So there are many things which we do it to bring the cost. Ultimately, the company wants to save the dollar, right? So, yeah. Yeah, Helm chart, right? Yeah, it's there. I can, yeah. So it's there in the slide, like now, very easy. Just go to the here, and you can install. How you can install? Just run this command, which is you need to add the repo first. You need to update the repo, and then below you can, if you want to run on a high availability environment, let's say you can, run this. Otherwise, if you want to just run it on single standalone node, right? You can just see this standalone section. For your, let's say, POC purpose, you can just go to the standalone section and just execute this command, and it will install a Helm. The Kyverno using the Helm. Any other questions? Okay, I think that's it. Yeah, if anything, just let me know. I'll be here on around. Yeah, thank you for joining. Yeah.